probably the most difficult thing with this question is going to be getting the right window settings so that you can see things, okay? But again, I'll give you some tips here. 75x squared minus 1800x plus 60,000. So, you know, what am I thinking here? I don't know what the answer is, but n is a number of thousands. So, you know, is it reasonable for the company to produce 100,000 items? I don't know. I don't know what this is about. But I think if we went to 100, that would be more than enough, maybe too much. So I might start off with going up to n equals 30 or 40 or 50. Okay, I'm just going to try 50. So in my window settings, I'm going to go from 0 to 50. And now how do I decide my y's? Well, I go to my table. This is, I think, the most efficient way to find out what's happening to your y is to look at your table of values for the x values you've decided to roll with. I'm going with 0 to 50 for x. So in my window setting, let's start at 0 and let's go up by 5. So I'll look at the cost for 0, 5, 10, 15, 20, 25, all the way up to 50. And I'm looking for a trend here. I can see that the cost is going down. Oh, now I lucked out. And I lucked out because I can see the cost is going down, these numbers are decreasing, and then all of a sudden they're going back up, which means the minimum is someplace from 0 to 30, really. And the numbers go up to around 60,000, roughly. So I might change this to 0 to 30 and go up to 60,000. And now I can answer the question. Okay, I do want to finish this because there's a little wrinkle in how the question is worded. It's a minimum left and then right. So it looks like the vertex is at 12, 49,200. So the answer to the question is 12,000 items. If it was what's the minimum cost, then the answer would be $49,200. Is that okay? Any other questions? There are going to be some of you always in a class that find this process frustrating to get the right location. And the nice thing about what we're going to do today is we could do it algebraically after today. That being said, some of you will not like the algebraic method, but you do need to know how to do it. Okay, so we're going to move on today and look at what is called the 20.3.3, called the process of completing the square. And this, what we were just dealing with, is a perfect example of why completing the square might be helpful. I believe it was 75x squared minus 1800x plus 60,000. I think that was the function we were just dealing with. It wasn't x, it was n. So if, and this is in standard form, if this were in vertex form, you could just look at the answer, right? Because in reality, was the vertex at 12, 49,200? So in reality, this is the same equation. So if you knew how to go from the standard form to the vertex form, you could do that, and then you could just look at it and go, well, the vertex is at 12, 49,200, so the answer is 12,000 items. That's what completing the square accomplishes. Completing the square goes from standard form to vertex form, and we need to know how to do it. So just a quick review here, and the format of this may look different than your note package. I haven't had time today to make this perfect. But when a quadratic function is written in the form that we call the vertex form, we know almost everything about the graph. The vertex is at P comma Q. The axis of symmetry is x equals P. The parabola opens down when A is negative, up when A is positive. And there's this stretch factor, which I've said numerous times I don't really care too much about in this course, but it's going to become more important next year. Quadratic functions, however, are mostly, almost always written in standard form. They're not very often written in vertex form. They're very often written as y equals ax squared plus bx plus c. And we've already mentioned this. This doesn't tell you much of anything, does it? Not in terms of the important details. It tells you the y-intercept. So going back to the question that Isaac had asked about, this right here was not very informative about the question, was it? So we had to rely on technology. So what we are going to be doing is working on converting from ax squared plus bx plus c to f of x equals a times x minus p, quantity squared plus q. But we have a warm-up because there's something about this form, this vertex form, that we need to talk about. You're asked to simplify each of the following perfect squares and write them as x squared plus bx plus c. So notice something. All of these binomials are being squared, so that's what makes them a perfect square. If I say, is 5 squared a perfect square? The answer is yes, because it's 25, because it's 5 squared. This is really important. I know it's Friday afternoon and you guys are tired and it's been a long week, but I want to talk about this. Is 81 a perfect square? Yes. And as soon as you say 81 is a perfect square, I come back with this question. What is it the perfect square of? It's the perfect square of 9, isn't it? Because it's 9 squared. Is a 16 a perfect square? Yeah, because it's the perfect square of 4. So is x plus 4 squared a perfect square? Yes. What is it the perfect square of? X plus 4. Right? Whatever this is equal to, it's what you get when you square x plus 4. So we're going to do this one together. This is x plus 4 times x plus 4, which is x squared plus 4x plus 4x plus 16. So remember, when you're squaring a binomial, you don't just square the x and the 4. You have to write it as that binomial multiplied by itself. We, of course, simplify that. I just want to give myself a little bit more space here. To x squared plus 8x plus 16. So what I would like everybody to do is take a minute and do the same thing for the other 3. I suspect that many of you don't need to write all these steps. It's grade 9, multiplying binomials. I do want to point out something to you, that if the sign in the binomial is positive, then the sign on the x term is positive. If the sign in the binomial is negative, the sign on the x term is negative. That's kind of a pattern that we need to be familiar with. And now the question that I'm going to ask you is a tricky one. It's a puzzly one. What's the relationship between B and C? So I'm going to write down these 4 things up here. You don't need to write them down, but I want you to see them in the same place as the question. One was x squared plus 8x plus 16. One was x squared plus 10x plus 25. One was x squared minus 6x plus 9. One was x squared minus 24x plus 144. Did I get them right? So we're comparing all of these to x squared plus bx plus c. So in this first one, we get b equals 8 and c equals 16. Okay? So what I'm asking you for is what's the relationship between b and c? But if you said, oh, if you double b, you get c, I would say that's not right because that doesn't work for the other 3. So I'm asking you to use your brain and try to figure out what you could do to B to get C in every case. And I want to give everybody a minute, just a minute or so to think about it before I start taking answers. Or I suppose you could turn it around and say, how can you get B from C? But there's a little bit of information that's lost in that process. And it's, I think, more important that if I give you B, you can figure out C. How many of you have it? What is it, Reagan? Right. If you take B, divide it by 2, and then square that result, you will get C. And notice that that works even if B is negative. If I take B, which is 8, and I divide it by 2 and square it, okay, so I'm taking B, just want to make sure you see this, we'll do that. I'm taking B, I'm dividing by 2 and then squaring it. 8 divided by 2 is 4, 4 squared is 16. If I try that here, 10 divided by 2 squared, well, half of 10 is 5. 5 squared is 25. Negative 6 divided by 2 squared. Negative 6 divided by 2 is negative 3, but when I square it, it becomes 9. This is very, very important. Before I write this down for you, I want you to remember that these are all perfect squares. They are called perfect square trinomials. And you don't have to write that here. You can write it in question 1 where we had our answers. This is a perfect square trinomial. Whoops. This is a perfect square trinomial. This is a perfect square trinomial. This is a perfect square trinomial. And in a perfect square trinomial, C is always half of B squared. As long as the leading coefficient, the coefficient of the x squared, is 1. Okay. So what is the answer here? Well, the answer is given on the next page. If you take a look at the top of the next page, I think is how I organized it. In a perfect square binomial where you have x squared plus bx plus c, if you divide b by 2 and square it, you will get c. So why are we even looking at this? The reason is, and you do not need to write this down, nor do I think you want to write this down, that we are looking at trying to get quadratic functions to look like this. But this is a perfect square trinomial of the type we've just been talking about. Okay. So we're going to use that property to complete the square. When you go from standard form to vertex form, that's called completing the square. You ready? You guys are just pumped up for this, I can tell. There is a correction to be made in your handout. The question says, convert each of the following quadratic functions to standard form. It should say to vertex form. They're given to you in standard form. And as we go through the first one, I would like you just to play along. Just go, okay, I'm going to do what he says. And hopefully you start to understand why what we're doing works. Okay. So I'm going to rewrite this. Let's rewrite it as y equals, just because some people don't like that function notation. But now I'm going to rewrite it this way. I'm going to rewrite x squared plus 10x plus 16. I'm going to just ignore the 16. I'm going to file it away someplace. And I'm going to ask myself, what number would I add here to make this a perfect square? I want this to become a perfect square trinomial. There's a number that will do it. How many of you know what the number is? It's half of b squared. This is what we just learned. This is the most important thing so far. The number c that you add on the end to x squared plus bx to make it a perfect square trinomial is found by taking b, dividing it by 2, and then squaring it. So the number that we put here will be 25, because b equals 10, b over 2 equals 5, b over 2 squared equals 25. This is what we're doing in our head. Or on paper, I don't care. You're looking at b, you're dividing it by 2, and you're squaring the result. And it will always be plus, because when you square b over 2, it will always be plus. Okay, so now, I started off with this function, which is written in brown. And I've changed it. I can't just walk around adding numbers to equations unless I do the opposite somewhere else. So what I'm going to do is, since I've added 25, I'm going to take away 25. And if I said simplify that whole line now, you'd go, well, 25 minus 25 is 0. So I get x squared plus 10x plus 16. We don't want to do that because then we're working backwards. What we want to do is write this in factored form. So now I'm going to go back and look at all of those perfect square trinomials that I wrote here for you. I'm going to erase everything else. I just want us to focus on these perfect square trinomials. This came from x plus 4 squared. This came from x plus 5 squared. This came from x minus 12 squared. This came from x minus 3 squared. Am I correct? I'm good with my memory there this afternoon? Okay. So the question is, how would you go from this to that? Yeah. I don't want to, yes, but I don't want us to look at this number. I want us to look at this number. I want us to focus on B in answering this question. And the answer is the number that we put with the x is half of B. And the reason I want to say that is if you take negative 6 divided by 2, you get minus 3. If you take 8 divided by 2, you get 4. But if you just think square root, people are going to go, oh, well, the square root of 9 is 3, and they'll write plus 3. So the bottom line here is when we now rewrite this whole thing, this part here, this perfect square trinomial, is going to become x plus 5 squared. And you know what? Maybe you can do this just, you don't have to do it on paper, but will x plus 5 times x plus 5 give you x squared plus 10x plus 25? Sure. So what we've actually done is we've factored this into x plus 5, but we're writing it this way. Oh, but we have this, 16 minus 25, which is negative 9. And it's in completed square form. It's y equals 1, x minus negative 5 quantity squared, minus 9. So now we can look at this and say p is negative 5 and q is negative 9. I really am not sure that we need to spend a lot of time graphing or answering the rest of this question, but I want to just go off script here for a bit. Put y equals, put the original function in your graphing calculator and get a zoom setting that allows you to see the vertex. Zoom 6 is the starting point. I can see the vertex. Anybody want to take a stab at what the coordinates of that vertex are? Well, negative 5 comma negative 9. But we determined that by completing the square, not by looking at the graphing calculator. So I'm going to take a gamble here as a teacher and say, let's not worry about writing everything down. I would say at this point in time, you should know, we'll do a quick sketch, that the vertex is at negative 5, negative 9. And the parabola opens up. I don't care if we list everything else. I think we've done this over and over again. This is a parabola that opens up. That means there's a minimum value. What's the minimum value? Negative 9. Where does it happen? Negative 5. Where's the axis of symmetry? X equals negative 5. What's the range? Y is greater than or equal to negative 9. Do you get my drift here that all of these details that you're being asked for in this question are things that are not new? So I would rather not spend our valuable time doing stuff again and again and again. Okay? You need to focus on going from this to the completed square form. So let's try another one. X squared minus 6x minus 20. The first thing you do is you take that minus 20 and you move it over someplace where we don't worry about it. By the way, don't move it too far over because sometimes people do that and then they forget that it's there. It's so far out of their field of view that they don't include it. And now what you're going to do is you are going to add, I'm just using a different color here to impress on you that we're changing that side of the function. We're going to add a number. And we're not going to arrive at the number by closing our eyes and throwing a dart at a dartboard. We're going to pick a number that makes it a complete perfect square. The number we add in here is we take b, divide it by 2, and square it. So we are going to add 9. Oops. How can I write this now? And in case it hasn't become clear, and it may not have been, this perfect square trinomial that we build is going to be your x minus p squared. That turns into the x minus p squared. What will it be in this case? We're going to have y equals x minus 3 squared. How come? Because half of b is negative 3. In other words, the number that goes down here in your final answer is what you got when you divided b by 2 but didn't square it yet. Is this correct? No, it's not. Because as soon as I said plus 9, think of that equal sign as being like the pivot point on a teeter-totter. As soon as I added 9, it's no longer balanced. I can either add 9 to the other side, which is, some teachers will tell you to do that, and then you subtract it. But if I'm adding 9 to the right side, I'm going to immediately take 9 away on the right side somewhere else. So I need to have minus 9 here. And these two numbers are going to produce your Q. Which would mean A is 1, P is 3, Q is negative 29. That would mean this is a parabola that opens up with a vertex at 3, negative 29. So what it would look like, what this function would look like, this original function, is at 3, negative 29, the vertex would be there, and it would open up. And, you know, the other details, x and y intercepts and all that, I really don't care about. It's just not important today. You could figure out the domain, range, axis of symmetry, etc. Try one more. 3x squared minus 18x plus 20. Now we have an added problem. In any completed square form, it's x minus p. So this part, which is the perfect square trinomial, has to have x squared in it. It has to have, come on, 1x squared. There's an a here that you're going to multiply the whole thing by, but it's got to have 1x squared. This does not have 1x squared. We need to arrange it so that it has 1x squared. And you don't do that just by, oh, erase the 3. You can't do that. But what you can do, we're still going to bump that 20 out of the way. We don't want it to interfere with what's going on. So we're going to have plus 20. And now we're going to look at these two terms and factor a 3 out. Because if I factor 3 out of x squared, it becomes 1x squared. And this is the only type of trinomial we know how to turn into a perfect square, the one that has 1 in front of the x squared. I take 3 out of negative 18x, and I'm left with negative 6x. I'm going to add some number. And then over here, I have plus 20. And this little bracket is pretty important. I want you to, oh, it's the same number as last time, isn't it? 9. You're going to add 9. You take half of negative 6, which is negative 3, square it, you get 9. So what should we do over here? Yeah. This is what we just added. We added that. That's what we wrote. So what should we write over here? It's a bit of a trick question. How many of you want to say minus 9? Would make sense, wouldn't it? But when I wrote 9, I didn't add 9. What did I really add by writing 9 there? I've added 27. Because that 3 is something outside of the brackets multiplied by what's inside of the brackets that I wrote in there. I've added 27. If you were to expand this out, you would get 3x squared minus 18x plus 27 plus 20. Look at this line and look at the question. What doesn't belong? The 27. So we've really added 27, which means I need to subtract 27. I don't subtract 9, I subtract 27. So in completed square form, this becomes y equals 3. This will be our x minus p squared. This is going to be our q. And what do I write here? I write x, and then I take half of b and put it in. So this parabola would be at 3, -7 for a vertex. And it would open up, and it would be very narrow because of the 3. Let's try one more. And then you're going to have lots of time to practice this. Then actually, after we do this, I'm going to show you guys how we could have done Isaac's question about that other problem with completing the square. The numbers are big, but it's pretty easy. All right, so I need to take that -2x squared minus 16x and separate it away from the 4. Before I think about adding c, remember that when we take half of b and square it to get c, that only creates a perfect square trinomial if it's 1x squared. It has to be 1x squared. Otherwise, that rule just doesn't work. So when we take a look at number 4 here, I have to arrange it so that I have 1x squared plus some numbers. So now I have y equals -2. I'm going to factor out to give me 1x squared, which will give me plus 8x. Because I factor a negative out of a negative, it gives me plus. I've always hated that. Look, when I factor, I don't know if this is helpful, or maybe some of you already do this. When I'm looking at what to write here, my brain says what multiplied by -2 will give me -16x. And it has to be a positive times a negative to get a negative. So it's plus 8x. I'm going to leave room to add something. I'm going to close the brackets. I still have my plus 4 out here. So what do I need to add inside of the brackets? I take a look at b, which is 8. Half of 8 is 4. 4 squared is 16. So what do I do outside of the brackets? Whatever I did, I have to undo. And what I did was I wrote plus 16. But what I've really done is I've subtracted 32 from that current side of the equation. Because -2 multiplied by the 16 that I wrote gives me -32. I've lightened the right-hand side by 32. I better weigh it down by 32 to get it back in balance. Okay. So whatever you put here is always going to be the opposite of what you ended up accomplishing when you multiply that number that you factored out by the number you wrote in. We have y equals -2. The perfect square trinomial always becomes your x minus p. The leftovers always become your q. This will be x, and then half of b is +4. Which means a is -2, which, let's be fair. Could you have figured out or told me a was -2 before we even started this? Sure, because it's -2x². But you wouldn't be able to tell me that p is -4 and q is 36. So this would be a parabola that would be at -4, 36 with a vertex. It would open down and be kind of narrow because of the 2. Let's go back and let's take a look at the question about the company and their costs. When I asked, are there people, do you think, that have difficulty in finding the right window settings? I have a reason for asking that, and it's that for me, sometimes it's just easier to complete the square. I'm going to fiddle and screw around with my calculator. I don't have time for that. I would rather just get to an answer. So when we look at Aaron's question, which was, I'm going to say 75x² minus, not Aaron, geez, I'm really sorry. Isaac's question of 75x² minus 1800x plus 60,000. Is that right, first of all? That was it. So if I want to find out where the vertex is, I would move this 60,000 over. I don't want to make the mistake of doing any factoring with it. When you do your factoring, it's only with your x terms. Okay. So I can take 75 out of x². 75 goes into 1800. I want to say 12 times. Or is it 120? Is it 12? Oh, it's 24. It's 24. 24x plus our mystery number plus our 60,000. So what number do we add? Well, half of -24 is -12, which, by the way, is going to be your p. I don't know, I didn't ever really said that, but half of b is going to be your p, always. -12² is 144. Now I need to multiply these two. To get 10,800. And since I've really, in effect, added 10,800, I need to subtract 10,800. Does that look right? Okay. For some reason that doesn't seem right, but it probably is. So we get 75. This is x minus half of b, which is 12². There's your answer, right? 12. Because you want to know the x coordinate of the vertex. Plus, my brain is just fried. Is that 49,200? It is? Okay. And was that, in fact, the y coordinate of the vertex? Yeah. It's not a bad process once you get used to it. Anyway, this is what you're practicing today. On page 192, number 2, 3, 4, and 6.